Hi, I'm Kiran Kumar from Nature of Physics. Today topic projectile motion. A body projected with certain initial velocity making an angle other than 90 degrees with the horizontal. Here theta is other than 90 degrees with the horizontal. Then the path of the projectile in what path? Parabola path, that is taken as trajectory. This is called projectile motion. Okay, so that see there, this is two-dimension motion, 2D motion student, in which this is the x-axis and this is the y-axis, and initial velocity is u making an angle theta with the horizontal, so that the initial velocity is resolved into two component, that is ux is equal u cos theta, uy is equal u sin theta, and horizontal displacement is x and vertical displacement is y, and the body is moving in parabola path OAB student. Clear diagram is given, so that first horizontal and vertical components writing here clearly. First displacement, next initial velocity, acceleration and time taken student. So displacement is here s is equal to x, horizontal displacement, and vertical displacement s is equal to y. Okay students, and continuation. Next, initial velocity here ux is equal to u cos theta and uy is equal to u sin theta, clearly given in the diagram. Also horizontal initial velocity, this is vertical initial velocity student, so that ux is equal to remains constant, so that ax is equal d by dt of constant. So differentiation of constant is equal to 0, so that ax is equal to 0 student throughout the path. Okay, horizontal component of initial velocity or final velocity at any point on the projectile motion is remains constant. Further I will give to you proof also student, so that ux is equal constant, nothing but ax is equal dux by dt, but ux is replaced by constant. Differentiation of constant is equal 0, that's why ax is equal 0 I wrote student, and ay is written as minus g because of upward direction student. And next one is here time is same, t is equal t, here also t is equal to, there is no change, time is remains constant for the horizontal and vertical displacement student. Now I am going to explain the horizontal displacement and vertical displacement. Before going to that, there is a initial velocity. Initial velocity u bar is equal to ux I cap plus uy j cap student, where u bar is equal to ux is equal to u cos theta I cap and uy is equal to u sin theta j cap. Okay student, and continuation horizontal displacement, the basic equation s is equal to ut plus of at square student. See there, horizontal displacement is x and this is the vertical displacement y student. Horizontal displacement is x. So already given the values clearly here. Again I don't want to write student. S is equal to how much there? S is equal to x. Next, u is equal to how much student? Ux into t plus half into ax into t square student, but ax is equal to 0 student, so that x is equal to, we are getting ux is equal to u cos theta into t plus ax is equal 0, 0 into anything 0, otherwise you can write 1 by 2 into 0 into t square student. Next step, x is equal to u cos theta into t student, this completely become 0 student, so that I can write now here t plus 0 writing. Now x is equal to u cos theta into t student and x divided by u cos theta, which is equal to time taken t student. Now I can write this is equation number 1 student, and this is equation number 2 student. Individually I gave you horizontal displacement is equal to x u cos theta into t student. From this t is equal to x divided by u cos theta is equation 2. And continuation, next I am going to write the vertical displacement there student. So for this vertical displacement, the basic equation again I am using s is equal to, we can write ut plus half at square student, and here s which is equal to written as how much student, y. Again I don't want to write student y, s is equal to y, so that directly writing there. Okay, see student, y which is equal to u, that is uy into t plus half into ay into t square student. S is equal to y, u is equal to uy, a is equal to ay I wrote student, and values replacing in the next step, that is y is equal to uy is equal to, here clearly given u sin theta. Okay, t as usually I wrote student, plus half into ay value is minus g into t square student. So y is equal to, I am getting u sin theta into t minus half into gt square student, minus here I wrote, and continuation, this is taken as equation number 2 students. In this equation I am replacing there, here equation 2 in equation 2 in equation 3 student, this is taken as equation 3. Now y which is equal to u sin theta into t value, that is x divided by u cos theta student, minus g divided by 2 into t value is written like this, x divided by u cos theta whole square. Now here u is get cancelled student, I am getting y is equal to sin theta divided by cos theta, okay, into x minus here g into x square divided by 2u square cos square theta student. So finally I am getting there y which is equal to sin theta by cos theta is tan theta, okay, minus g divided by 2u square cos square theta into x square student. Okay, so there y is equal to final equation ax minus bx square student. This equation give path of the projectile is a parabola student. Now I can write this is equation number 4. So equation 4 represent path of the projectile, is a parabola student, and here I can write both values are there, one is a and another one b student. Okay, I can write here a is equal to tan theta student, and b which is equal to g divided by 2u square into cos square theta. Okay, so now equation 4 represent the path of the projectile is a parabola. This is projectile motion.